right, this is the last set of notes for the entire blended course, and there's only 3 problems on it. Let's get to it. We're going to solve higher order polynomials by factoring. Quartic polynomials are degree 4. So the degree 4 here means that there will always be 4 solutions, real or imaginary. Let's jump right into them. We're going to go right, we're going to have like a lot of factoring methods in this problem. 4 terms means I have to factor by grouping. Put parentheses around my terms and find the GCF. The first set of parentheses has a GCF of x cubed, and you'll be left with x plus 3. The second set of parentheses actually has a GCF of 27, which is x plus 3 again. Now when I rewrite that, I get x cubed plus 27 times x plus 3. Now I'm actually not done, because we learned, or we reviewed in the last lesson, how to factor the left guy here. That's the factoring method we like to call our friend SOAP. That is different, or sum of 2 perfect cubes. The x plus 3 stays put, but I need to figure out how to fill in the blanks of this factored form. So I start by taking the cubed root of x cubed, which is x. That goes in our first blank. Then I take the cubed root of 27, which is 3. That goes in the second blank. The short set is easy. Now I fill in the trinomial. The first blank of the trinomial comes from squaring the first term of x. The last blank of the trinomial comes from squaring the 3. And the middle blank comes from multiplying them together. You're going to fill in the symbols here using your idea of SOAP. We started with a plus sign, so we have same, opposite, always positive. That whole thing, the 3 factors there, are all your fully factored form. Now we said we need to have 4 solutions. The first 2 are actually going to be pretty easy. I take x plus 3, set it equal to 0, subtract 3, and I get a solution at negative 3. That's one of them. I'm going to skip the trinomial for a second here and go down to this guy. I'm going to set the other x plus 3 equal to 0, subtract, and I get negative 3 as the other solution. So that's 2 of them. They're both at negative 3, which is okay. That just means the root has a multiplicity of 2. And then I'm going to find the middle one. In order to solve this, I'm going to need the quadratic formula because the middle term is odd. So x equals, take the opposite of 3, which is negative 3, which is positive 3, plus or minus the square root of b, which is negative 3 squared, minus 4 times 1 times 9, all over 2a. All right, let's simplify this. We take our calculator, and we're going to type the radicand into decimals. So I will have, let's see, negative 3 squared minus 4 times a times c is 9. That equals negative 27. So I have negative 27 under the radical here, all over 2. Now the square root of 27 breaks down to be radical 9 and radical 3, which is 3 radical 3. So when I simplify this, I get x equals 3 plus or minus 3. There's a negative, so I have an I, radical 3 over 2. That doesn't simplify anymore, so those are my 2 other roots. Now, if you wanted to check your answer, you could type this into decimals. You won't be able to see the imaginary roots, but you can at least see the real roots and make sure that you did those right. All right, now I can't see if I zoom out, it's just going to look, it goes up, but see how I have a bouncing off the axis at negative 3? That's that multiplicity of 2 that we found by solving. All right, 2 more problems. The next one's a little bit easier. Y to the 4th minus 16. Now, this one is kind of tricky. Y to the 4th and 16 are actually both perfect squares, and there's only 2 terms, so I actually have to use the method of difference of squares here. Now, in order to fill in the blanks, you have to take the square root of y to the 4th, which is y squared, and put a y squared in both parentheses. Then you take the square root of 16, which is 4, fill in your plus and minus. Now, I'm actually not quite done. What I'm going to do is y squared plus 4. I cannot factor that anymore. The plus sign blocks me. I can't factor it. So I'm going to set that factor equal to 0. And I'm going to solve. I'm going to subtract 4 from both sides. Get y squared equals negative 4. And take the square root. The square root of negative 4 is 2i. Oh, but I forgot something. When I take a square root, I have to put a plus or minus. There's technically 2 roots there, 2i and negative 2i. Those are 2 answers. I have 2 of the 4 that I want. The other guy, I can factor by difference of squares. Or I can do the same thing if I want. Let's just do the same thing. Y squared minus 4. Set them both equal to 0. I'll add 4 to both sides. Go y squared equals 4, and then take the square root. When I take the square root of 4, remember I always get 2 answers, plus or minus 2. Those are the other 2 roots. Again, 2 and negative 2, which gives me all 4. All right, last one here. I have a trinomial. No GCF, so I'm going to jump right into factoring a trinomial. Don't get scared away that the exponent is 4. It's going to be the same as regular split the middle. 4 times 9 is 36. 2 numbers that multiply to 36 and add to negative 13. Negative 9 and negative 4. All right, I'm going to split the middle here. 4x to the 4th minus 9x. Now be careful, the middle term has an x squared, so my middle terms have to have an x squared. That's the only tricky part here. When we factor there, you split the middle up, you have to keep the same exponent. And now we group. The GCF of the first guy is just x squared, and you'll have 4x squared minus 9. And then over here, I'm going to pull out a negative 1. That's the only thing that can come out of there. 4x squared minus 9. Well, I have x squared minus 1, 4x squared minus 9. And one thing you can do, you can either set those equal to 0 and solve, or you can keep factoring, because those are all difference of squares of 4 parentheses. The square root of x squared is x. The square root of 1 is 1. That's your first guy. Square root of 4x squared is 2x. Square root of 9 is 3. Here's your fully factored form. So now you set each of those factors equal to 0. And you should be able to solve those. So I'm going to subtract 1 on the first guy, get negative 1 as a root. Add 1, get positive 1. I'll show you this one here. I have to subtract 3, and then divide by 2. And I'll get a root at negative 3 over 2. And this next factor, I would add 3, so my factor, or my solution would just be positive 3 over 2. So that one had 4 real x-intercepts. All right, that's it for notes. Go ahead and flip the paper over, try the practice, and ask your teacher if you need any help.